let's talk about clovers, because that'll be different. So there we have a picture of a clover. If you had 14 clovers, how many leaves would you have? That's not too hard to think about, right? Well, 14 clovers, and they each have 3 leaves. We have to multiply, and we end up with 42. This is the process that we're doing, whether we recognize it or not. We understand that there are 3 leaves on each clover. We have 14 clovers. We multiply by this relationship, 3 leaves per clover, and we end up with 42 leaves. We can do things like that with spiders or chairs. You know, if you had 2 spiders, how many legs would there be? 16. Because you take 2 spiders times 8 legs per spider. If you have 4 chairs, how many legs? 16. 4 chairs times 4 legs per chair. It makes great sense when we're talking about familiar objects. We can do it with molecules too. If we have, say, 3 water molecules, how many hydrogen atoms would we have? 6. Each water molecule has 2. And if we have 3 of them, then we've got a total of 6. Let's just write that out. So if we had 3 H2O molecules, see, there's that stupid word. There are 2 hydrogen atoms per 1 molecule. And so we would end up with 6 hydrogen atoms. Okay? So what if we have something like this? We've got, find the number of moles of carbon in 2.3 moles of lead carbonate. Well, how about we do this first? There's a 3-leaf clover. What if we had 2.3 dozen clovers? How many dozen leaves would we have? Well, in a dozen clover, 1 dozen clover would have how many dozen leaves? A dozen. 1 clover has 3 leaves. A dozen clovers have a dozen leaves. 12 leaves. 3 dozen. Rewind. 1 clover, 3 leaves. A dozen clover, 3 dozen leaves. Right? So 2.3 dozen clovers would be, what, 6.9 dozen leaves. Did I do that right? 2.3 times 3? 6.9 dozen leaves. So don't let the dozen mess you up. And in this actual problem, don't let the moles mess you up. So here we've got 2.3 moles of lead 2 carbonate. And we want to know moles of carbon. That means we have to divide by moles of the whole thing. This is the unit I'm starting with. I want that to cancel out. Find the number of moles of carbon is what I'm looking for. The number, this ratio 3 to 1 of leaves to clovers was the same for individual clovers and for dozens, right? Because when you have the dozens, it's just, everything's multiplied by 12. When you have a mole, everything is multiplied by Avogadro's number. So we look at this, and we can ask ourselves, okay, in one PbCO32, how many carbon atoms are there? There's 2. So there are 2 carbon atoms for every 1 molecule or formula unit. That means there's to be 2 moles of carbon for every mole of lead carbonate. And so this is 2.3 times 2, which should be 4.6 moles of carbon. Any questions? Converting between grams of compound and grams of a constituent element. Find the mass of aluminum in 19 grams of aluminum chloride. So now we're coming slowly around to that original question of how many grams of sodium chloride could you eat and stay under the recommendation for the mass of sodium in a day. Here we've got the mass of a compound, and we want to know the mass of one of the components of it. So there's 19 grams of aluminum chloride. What's the relationship between the aluminum and the aluminum chloride? So we have 1 aluminum atom for every 1 AlCl3 molecule, right? Or we have 1 mole of aluminum for every 1 mole of aluminum chloride, right? It's from the formula. There's 1 aluminum in here. It's like tricycles. If you have a dozen tricycles, how many dozen handlebars do you have? A dozen, because each tricycle has 1. Yeah, it's got 3 wheels, but we weren't talking about the wheels. So this is the tricycle, aluminum is the handlebars, and the chlorines are the wheels. So you've got 1. So we've got this relationship of 1 mole of aluminum to 1 mole of aluminum chloride. 19 grams of this. We can't just apply a 1-to-1 ratio and say, well, there's 19 grams of aluminum in 19 grams of aluminum chloride, right? Because there's chloride in there too. The formula is talking about particles. The mass is not talking about particles. So we have to convert the mass to a particle unit and then convert back. So we're going to take 19 grams of AlCl3, and we're going to find out how many moles of AlCl3 that is per gram. And then we're going to have moles of AlC, I'm tired of saying that, AlCl3. Relationship between moles, and find out how many moles of aluminum, and then we can convert to grams of aluminum. It's getting smaller and smaller. I'm accidentally zooming in further and further. Do you feel like they sprung this question on you just out of the blue? Because that's what it seems like to me. This all of a sudden thing, they just ramped it way up. I'm sorry. What, in the previous problem, we were doing something like just right here in the middle. We were taking this number of moles of, what was it, lead carbonate, and figuring out the moles of carbon in it. And so that part is still here in the middle. But now, instead of a number of moles, we've got a mass. But we've learned how to convert between mass and moles. So we take that mass, we convert it to number of moles, because moles is related to particles. The formula relates particles. But then at the end we want grams again. So this middle piece right here, how many moles of aluminum in a mole of AlCl3? Well, it's 1 to 1, right? How many grams of aluminum in 1 mole of aluminum? Periodic table. 26.98. How many grams of AlCl3 in 1 mole? Well, we actually have to calculate that. There's 1 aluminum, 26.98. And 3 chlorines. $133.33. This means 133.33 grams of aluminum chloride is equal to 1 mole of aluminum chloride. That's calculating the molar mass. So 1 mole, 133.33 grams. 19 divided by 133.33 times 26.98 equals 3.8. So in 19 grams of that compound, you have 3.8 grams of aluminum. Is that a reasonable number? Is that a possible number? It is. If the mass of aluminum was greater than the mass of the compound, that's not possible. That's like saying in a kindergarten class of 20 students, you have 30 boys. Doesn't work, does it? The parts add up to the whole. Any questions about this one? So we've got these inherent relationships. Here's a picture of carbon tetrachloride. One molecule of that has 4 chlorine atoms in it. 1 mole of this has 4 moles of chlorine in it. And so that allows us to convert between moles of the compound and moles of one of the elements in the compound.